Hello and welcome to this week's episode of That Tech Show, the show that reveals the magicians behind the magic that is everyday technology.
Tudor Girba is on the show today and introduces us to the concept of moldable development with the Glamourous ToolKit which he created. Glamourous ToolKit is a modern evolution on top of SmallTalk which first appeared in 1972, and with this new twist, Tudor aims to find a faster route for us to understand the code in a system without having to read it, which, as we discuss, is what developers spend 50% of their time doing. Glamourous ToolKit can be used anywhere by anyone, and it's a replacement for your usual development environment. So take a listen, it might just change the way you work and save you some time in the process.
My name is Tudor Girba. I'm the CEO of Think. At Think, we are a company that is focused on making the inside of software systems explainable. We think that this is the single largest, most important problem in software engineering today. And I'll be very happy to talk about that.
Awesome. Well, how have you solved that, I guess, is the first question.
I think it's perhaps more interesting to talk about not so much about the solution or the current solution, but rather about the problem, or start from the problem. So we started from this simple, realization. So I was writing my nth paper. I started in academia and in research, and I was writing my paper, and I was writing it, I was in the space of software evolution, understanding software, and very often we would motivate the research by saying developers spend 50% of their time reading code. And indeed, there is the oldest reference to the subject goes back to the late 70s. And so, and then since then, we have quite a number of other pieces of research that actually point exactly to the same direction. And then I talked with several thousand developers by now, and I asked them, do you agree that you spend 50% or more of your time reading code? And the vast majority of developers say yes. And as I said, the research points to that thing as well. But so when I was writing this abstract, and I vividly remember that point, and I realized, well, if we know this for 30 plus 40 years by now, if we know this for so long, what did we do in the meantime? And it's not that there was a shortage of research on the topic, but it's that, is it possible that maybe we have asked the wrong question? And that's basically what put us on this track of where we are right now, where we are talking about a new way of programming, which we call moldable development. We are creating a new kind of a development environment, which is, you can find at Toolkit, Glamourous Toolkit. That's the name of it. And the essential part there is that when I talk with developers, I also ask them another question, and that question is, when was the last time you heard developers talk about how they read code? So not about the code that they read, but about how they do the reading. And it turns out this is not a subject of conversation.
Yeah. But it must be so diverse, though. There must be so many different ways people just read code.
But in fact, it's not, because it's implicit. And that's the thing. Think of it in business terms. It basically means that we're spending the single largest chunk of the budget that we already have on a single activity nobody talks about. Right? Nobody talks about, it's not explicit. If it's not explicit, it has never been optimized. Single largest expense. And then, of course, people go around and say, oh, we don't have time. Of course we don't have time. Right? So the very first thing we should do is not talk about the solution, just talk about the problem. For example, whenever you're doing going into an agile or trying to get people to work more agile, what do we do, right? How do we get them to do that? I mean, you can tell them, do this, right? But that's not going to happen. That's not going to make it work. But if you can make them make the problem explicit, you just increase the chances of a solution popping up. And that's much more interesting than the solution. Now, of course, we have a decade of asking this question behind us by now. So we do have some answers, and we do have the beginning of that conversation. We know that this is a conversation that we should have as an industry. But of one thing, if there's one thing I'm convinced of, is that as soon as we'll start that conversation, so many new things will happen that we cannot predict right now.
So let's get into this then. So that piece of language, the 50% of developers spending their time reading their code, that really stuck out to me because I'd seen that you'd given that in other presentations as well. And the thing that stuck out was the follow-up, that actually what they're trying to make is decisions. And so can we make that reading more effective? So I presume that was the origin to the Glamourous Toolkit. Is that was what you went after?
Yeah. So as I said, I started from saying, well, we must have asked the wrong question. We must have had the wrong hypothesis. And when I look back, for example, at all the work that I've done to that point, and a lot of the related work in research, a lot of it is about creating the tool on which developers will click, and it will instantaneously make their life better. And I've been looking for that tool for a long time. But at the same time, I was so lucky to be in a research environment where tools were encouraged, not just it were not. It was not just the paper. The paper was actually the side effect. The more interesting was the tool. And then, of course, when you're in an we're in an environment where engineering is interesting, platforms emerge. So we were very good at creating these kinds of platforms to the point in which we were calling the platform like a paper writing tool. So our goal was to basically create faster and faster experiments. And at some point we realized, well, we can actually solve actual problems like that. So when I left academia, I didn't exactly know how the problem should be solved, but I left it with the goal of actually pursuing this thesis. And I thought that in academia, if we did not end up affecting people's lives, like developers were still reading code for 50% of their time, 40 years, 30 years after we knew about the problem, then maybe you're doing something wrong. So I went there and I said, okay, let's solve problems. So I did consulting, and I took the first run, and I was basically looking for the repeatable pattern. And I took the first project and the second one and the third one, and I was looking for what would the tool be that would solve this problem. And then one thing that struck me very quickly or very early on was that in fact all problems were different. And for me to be relevant to the specific project, I had to tweak my tools in some form to produce some visualization that would lead to some sort of an action. And this is what it hit me, that in fact the whole purpose of this reading is in fact to understand enough, but not to understand in general. Like there are all sorts of understandings. Like for example, you would read Nietzsche in a way to get some understanding that is not necessarily something that you would use on a day-to-day basis. But the way you read code is different. It's a different understanding. And that understanding is guided very much by the intent of actually making a change. It's the decision-making that it's the core underlying activity. Of course, now this sounds like generic and so, but that for us that was the thesis that I put forward 12 years ago now. And we've been validating that one ever since. So the original project we were doing in research, that was called Moose. But that one has a long history as well. There was one of the largest platforms in software analysis. And Glamourous Toolkit is a new project that said, well, what if we apply this one to everything software, not just some static analysis, for example. And this is how we got to today. So what exactly is it that we are saying? What we are saying is every single development problem is is embeds in it a data science problem, because everything around software is data. Data does not have a shape, but in order for us to reason about it, and which should be the step that comes before decision making, I believe. So in order for us to reason about data, we need a specific shape. We need a concrete thing that we look at or that we perceive. And a tool provides that shape. So what we are saying is that every development problem should be treated like a data science problem, in which we create custom tools while we work for every single problem. And that's basically what we're doing, and that's what we call moldable development. And we are now to a point where we have several years of experience of actually using this in practice and building projects and actually solving business problems too. And we can now reasonably confidently say that this is very likely the next major step in software development. And it will add, because it adds a new feedback loop that simply didn't exist before. So if you think about feedback loops, right, we can just let's take a simplified history course. So first there was code, and then tests became code. And when tests became code, there was a new feedback loop. And interesting enough, that feedback loop introduced, of course, testing, right? So you would say, okay, so we do automated testing, but it was interesting how it changed the way we design, right? Or how we think about design. It also changed the way we started communicating with business. And because now business could have a way to maybe specify tests, or at least have some idea of what's going on inside the system, which was otherwise completely opaque. But then if you fast forward a decade or so, and then we get to DevOps. And DevOps introduced a new feedback loop as well, right? And the interesting thing, again, like, sure, you can look at the cost of a deployment, and indeed it went down. But the interesting side effect of DevOps is that you extract the real value when the business learns how to change the business model, because now they have the opportunity of learning from a system live, right? So from how the system is being used live. And that's like a huge fit, like it's a complete new kind of economics that you would apply to a system development or system evolution that was simply not available before. And what we're saying now is that the next step that we see is that tools will become code. So right now, people are using tools rather statically. And we find developers clicking a lot. Every time they want to do something, they kind of click a lot to go from A to B. And they click on static things, right? Configuration, pre-configured or semi-configured types of tools to support maybe visualization, to support some sort of an understanding of the system. And then they are left with piecing together the overview in their heads. And that's very, very expensive. And it's not just expensive, but it's just a terrible experience. And so what we're saying is we can construct this overview customly, like while we work on the problem. And that not only makes us significantly faster, it makes us smile many times more. And then there is another, so this is the direct thing. But the interesting thing, again, every feedback loop has this secondary effect that, and that's what we should basically look at. And the secondary effect that we see here is we can actually get to have conversations about the inside of software systems with any stakeholder that is interested in a software system. So we are at Think, we found ourselves through consulting. So we are a consulting company, and we solve odd problems or difficult problems. And so when we go, we work with several kinds of projects, but two larger areas are either legacy systems. So maybe some corporation, they have this large thing and something has to change, and they have to figure out how to change it, but more importantly, how to actually not just to decide which direction to go, but how do you steer this thing for the next 1 or 2 years or so, which is the trickier problem. And so that's one. And the other kind of project that we work with are startups. And in the case of a startup, we would work with a company to have them explore a domain very, very quickly. Mm-hmm. And that exploration is most of the time is less on the technical side. So it's not like, oh, I'm going to choose, JavaScript or Python or whatever. That is one kind of an exploration, but that's not the kind of thing that we do. We explore the business model. And the business model is interesting to, like that one you can only have, there needs to be technology, but that's not the driver. The most interesting thing is to get the people that understand the domain to iterate quickly. Mm-hmm. And the key here is iterate before you have an app. Now, of course, ideally you want to have and go and iterate, with the real system. And by all means, if you can do it, then you should do it. But there's so many things that you can get feedback on well before there is a finished thing that you would give to somebody to play with. So, but when we work with the legacy system people, we noticed that there are two concomitant fears. On the one hand, people are afraid that, we will not be able to change this in time. And usually this means some sort of, there's usually with, when you have these larger corporations wanting to change the system, there's some sort of opportunity cost and around the corner for them. So, be able to compete with somebody that already digitalized, and you need to go and digitalize as quickly as possible. Because otherwise you're going to lose market share. So the problem there, the real costs there are not the cost of development, but the cost of not being able to deliver it. So that's one side, one kind of fear. And the other fear is the fear of changing it, because they simply won't know what's going to break. And it's excruciatingly painful to be in between those two fears. On the one hand, you have to change. On the other hand, you can't change.
Rock and a hard place.
Yeah.
Well, I think we've been through quite a few things there. There's an awful lot to unpack in that. I think it's really interesting that you talk about trying to shortcut that feedback loop. And I think it's really interesting you talked about tests and the DevOps side of things, because, you're 100% right. Or both of those things are shortcutting the feedback loop. So this is trying to do exactly that same thing, but in a much smaller way, I assume, because a lot of the stuff that is, we can't really explain fully on an audio podcast, but a lot of the platform is quite visual. You are sort of rendering views whether it be like a tree, for example, to actually represent data structures of what is under that code. And I think it's really interesting you talk about the legacy environment, because I'm working for an organization at the moment, going through a re-platform, and I was talking to one of the engineers who deals with a big legacy portion of the platform, and she described it as 30% Java, 20% Kotlin, and 50% hieroglyphs. So I presume, like, the hieroglyphs part, your tool would actually give a little bit more clarity to what do these hieroglyphs actually mean. Can you actually unpick that with that? So I presume the legacy aspect is a really interesting angle. Is that part of what you came at it from, or is this just a happy consequence?
No, that's exactly the place where we came from. So that was the first problem that we played with. It just so happens that it has many more implications also on how we design, but we can go into this. So let's unpack the legacy part. So as I was saying at the beginning, the one thing that Glamourous Toolkit is not a tool that people will take and click on and immediately will transform the hieroglyphs into something readable, because that never works like that. Here's why not. Software is incredibly contextual. In fact, it's likely, to my mind, the most contextual structure we've ever created as human species at such a small scale. So because of that, we cannot predict the specific problems people will have. We can predict classes of problems that people will have, but not the specific problems. But every tool you click on bakes the question in the click, bakes the problem in the click. And that's why all tools fail. And at the end, people go and read, because reading is the most flexible tool we have at our disposal to deal with any context. The only problem with it is it's horribly slow, and it's not particularly efficient either. So that's basically what we need to deal with, right? So when you have a legacy system, and maybe, let's say not a large system, 250,000 lines of code. If you want to read that one, right, let's say one line, you read one line in 2 seconds. And let's say that you can keep it up for 8 hours. It would take you about a person month to read the whole thing. Just to read the whole thing. And that thing changes every day, multiple times per day. And the question, and then people will, like we have all of these ideas that this problem existed for a long time, but people said, okay, let's encapsulate change. First, people said, let's follow a plan. Here's the architecture, follow that one. Well, that didn't really work out. Then people said, oh, let's throw away all the pictures. But then people said, oh, now I cannot find my way. Well, they didn't find their way either before. They just thought that they did. So that's a problem. And this problem existed for a long time. But no matter the rules, no rules will be able to keep this one in check. So the only other alternative is to say, well, a system is an emergent artifact. And so architecture is an emergent property. Architecture is not something I follow necessarily. It's something that I have to observe. And of course, if I don't like it, I'm gonna steer through it. So like in a couple of other episodes in your podcast, you were mentioning, for example, complexity theory or the Kinefin framework, right? So if you think of that from that angle, that's much more interesting when you think about the evolution of a system. So the ability to observe is actually key. So how do I compress that 1 month of reading into something that I need for the next 5 minutes? That's the interesting thing. And that's why we look at software as everything around software is data, and this is nothing but a data science problem. And we have applied data science thinking to other domains. We just have to apply it to our own. That's it. It's not really a big deal there. And so, for example, right, when data science tools went from clicking, like what you do in Excel, to something like programming, what you would do with a Jupyter notebook, it completely changed not only the kinds of problems that people were dealing with, but how the data, the decision-making flow has been influenced by that. And that's exactly the same lessons that we can take one-to-one, apply them to software development. But of course, for that, we have to go and do away with the kinds of tools that we're exposed to today, because those tools are going to want us to click when the problem is not a clicking problem, it's a programming problem. And so that's what we mean by tools having to become code. So what Glamourous Toolkit is a first environment that shows how far can you go when the environment is a language rather than a set of features. So it's a language that you can combine in many, many ways. And when we say many, many ways, I'm talking about millions of ways, not about 10 ways or so. So that's the kind of a metaphor that we have in mind.
Yeah, well, I think actually from the research that we were doing into exploring the app, basically, I think that was Sam's first response, wasn't it? Sam, what was it you said?
So where can we use this? Like, who is, like, how can you actually apply this toolkit? Is that what?
No, you said, what can't it do?
Oh, I see. Yeah.
See, I teed you up there and you came out with the wrong answer. No.
Let's just retake that.
What was it you said, Sam?
What can't it do? I just could not imagine. What can't this tool do?
But that's very true. I think the looking at it, it was very, from your examples as well, the videos we've seen, it is very hands-on. It is very low click. But to the what can't it do question, what is the learning curve for actually picking that up? Do I have to learn a whole new language for this?
Yeah, well, yeah. So that's a very good point, and this thing with the what can it do, it's a very interesting. I love it. But the reason this is interesting is for me is because the what kind of do we are so used to comparing tools with like the tools that we typically compare against, we can enumerate the kinds of things that it can do.
Mm.
But when I give you a language, like for example, I give you a programming language, you will just not ask what can it not do, because it's not something you do not expect the language to enumerate the kinds of things that the language can do on one or two hands, right? This is not how it works, right? But we are so into this app world where the app has the one thing that it does, right? We're so trained by now to think like that it's difficult to now, oh, what do I do when I can do so many things, right? That's one. But the second thing is to keep in mind is, and we have a blog post showing how large is it, right? Because well, I mean, maybe it does so many things, but it's also like the size of Windows. But it's not. It's like 500,000 lines of code. So it is not a large thing, right? But yet it can do so many things. It can be transformed into so many things. We say it can be moldable in so many things. And that's the thing. We look at the environment as being a language. And maybe this is hard to convey, but so there used to be a time when computers were dedicated to a specific task. Like they could do, like they could solve equations. And that's like you would have this whole building only doing that. There was not doing anything else, right? And then some crazy people would say, oh, a personal computer would be there to do all sorts of funny things. And then people say, well, we'll never need that. Because when you come from a place where like you would have a whole utility and a whole appliance, you would pay $1 million for it, and it would do, it would do accounting for you. That's what it would do. You don't see yourself like saying, oh, let's invest $1,000, and then all of a sudden you can do, 100,000 other things, right?
Yeah.
It's just not conceivable in that space. But that's the kind of thing that we put here. So how do you learn it? And that's a very good question. The way you learn it is not like a tool, but like a language. And you should have it as the expectation should be such that you learn it like a language, and you can evolve with it, just like you do with the language. You can expect to write a first program in the language within maybe a day or two, or maybe shorter, but you definitely expect that in half a year from now, you'll be better at it. Because it's a tool for thinking, not a tool for doing. So now, Glamourous Toolkit is a SmallTalk system. So it is based on a SmallTalk dialect, which is called Faro. That's the base language and small.
Yeah, I was going to talk to you about the lineage because there's clearly SmallTalk, Faro, GT.
Yeah,
So
exactly.
talk us through a little bit about that, because obviously it's interesting you mention about it being SmallTalk based. How does that factor into how I develop it? Because I have seen some stuff where you're expanding your language. You're expanding your development environment using the Faro language, but there was talk certainly about being able to support multiple languages.
Oh yeah, we already are supporting multiple languages. So so the lineage is this is a SmallTalk system. It comes from Faro. Faro is a SmallTalk dialect, and pretty much all my research for the last 20 years was somehow happening around SmallTalk. And why SmallTalk is because I don't think we would have been able to come up with Glamourous Toolkit in another environment. But now that we know how it looks like, it does not have to be in SmallTalk. Now that we know the properties that the environment should have, we kind of know how to get it into other places. But the way we got here, so the first goal of Glamorous Toolkit was to answer the research question and say, how far do we go? How far can we transform the act of programming such that at the end, systems are explainable? Such that at the end, I can go to the business person, the one that is now in between those two panes, and I can have a constructive conversations, and we can transform those pains into confidence, into understanding, and making decisions because not because somebody drew something on a whiteboard. But back to the tool. So this is a SmallTalk system. The reason we are in a SmallTalk system is because it's so much easier to think about new perspectives in that environment. It's just not comparable. So in terms of the learning curve, but yeah, right now with Glamourous Toolkit, you can. So on the analysis side, if you just want to go and just reason about languages or systems that are written in other languages, we have, I don't know, we support a dozen of them, but we can also create new kinds of analysis infrastructures. In fact, by now we learned, when we do consulting, when we talk with usually we talk with business, so we typically solve the business problem, not the technical problem. That's another maybe interesting conversation. But when we talk with business, they often don't know. They can't describe to us technically how the system, what the system is made of. This is how low fidelity information they have when they make decisions. And this is that's nuts for me. And I've seen tens of millions of euros worth of decisions that were being made by people that did not understand anything about their system. So
this is a very truism, very much a truism, absolutely.
Yeah, but it went so extreme that once I've seen a company, it's a large company, and this was one of their core systems, and they couldn't tell us what language the system is implemented in, right? And because they said it's COBOL, but it turned out to be a variant of COBOL that was pretty much homegrown, and then they gave us a documentation about the language, but the documentation was 9 years old already, and it turns out that it was wrong because the language evolved in the meantime. The language evolved, right? Not the system. So we had to reverse engineer the language first, because the only thing that knew how to do something with the language was the hard-coded transpiler that would transpile that one into COBOL so that it runs on the mainframe. And we had to first reverse engineer the language, and then build up those kinds of tools, and then be able to be in some position to actually start reasoning about the system itself. This is how extreme it can go.
How do you get from the product side there, from the people who are making sort of business decisions about what the technology is going to be, how it's going to be built, who's it going to serve as a customer? How do you get from that to an IDE? Because a development environment is the total opposite scale, and why? That's normally a subset of the people in the business who care about the development environments, and also in a lot of places it's multiple development environments. It's whatever you're comfortable with, rather than the organization sanctioned development environment as it used to be in the past. But they're total opposite ends of the scale. And do the product business people need to care about the IDE?
Yeah, that's such a good question. So there are two answers that I can give. So first answer is, what do we do, from a consulting perspective? So from a consulting perspective, we use Glamourous Toolkit like others would use pen and paper or a marker and a whiteboard. By the way, whenever people draw something by hand about the existing system, that's a belief. Because that's a description of what the author that draws thinks or believes about the system. That's not what the system is. It might or might not be. You don't know. Now, pretty much all decisions that I've seen over the last decade were being made on beliefs. Now, that's not good in your regular life, but in engineering, that should not, that should not be how things should work. So from their perspective, from that perspective, we basically replace the whiteboard. Whenever we think about the existing system, we replace the whiteboard with a tool. So the only thing we use a drawing on a whiteboard is to say, okay, that's an interesting hypothesis about how you think the system looks like. Let's go and check it against the system, and then we make the system draw itself. That's the thing. But now let's go back to this second answer. Should business people care about the development environment? So let's actually turn this problem upside down. So why the development environment? How did we get to that one? Well, we got to this one because if you look at the end result, and the end result is that you have this system that have been created and nobody knows how to take them apart. And so, and you would say, okay, maybe this is an isolated case, it's just with these mainframes, but we see it with new systems. In fact, we got this chance of working, a couple of chances like that, working with corporations that have multiple systems that we wanted to take a look at. And some of them are like, 1 year old, and other ones are like 30 years old. And they all exhibit similar classes of problems. And that's like an interesting thing, because you would say, well, maybe, it's not just a property of these old, systems. Yeah, it's a pervasive problem. So if it's a pervasive problem, it means that the issue is systemic. Now, software is also, it has fractal-like properties, which means that in order to go and solve large patterns, you have to go and tackle or change small patterns, the smallest patterns, if possible. So when we worked on Glamourous Toolkit, we spent a good deal, the largest part of the last decade, just thinking of how do I change how I relate to a single object. Not to the whole system, a single object in the system. That's what we spend the largest time playing with. And it's because we are now comfortable with a new perspective of how do I deal with one single object, that we are in a position to start talking about all sorts of problems very, very fluently and actually affect large patterns. So, and this maybe that's a good point to mention, the ultimate motivation. And this is something that I call software environmentalism. You see, the problem is that we are creating systems faster and faster, but we are unable to recycle old systems. And recycling is taking a system apart and refurbishing it for new purposes. And we are unable to do that. So from that perspective, we actually behave pretty much just like the plastic industry. We're just singularly focused on how do we create things with no regards of what's going to happen after we have created them. And that doesn't scale, right? We saw it in the actual world. That kind of thinking doesn't work. And I think that also given the problem, I think we have, given the size of the problem, we're basically touching everything in our society with software. But then at the end of the day, we end up swimming through software that nobody can really understand.
You're trying to tackle the virtual ocean full of legacy software.
Yeah, and then you say, well, how do you take a system apart? Before you can take a system apart, and there are lots of things there, but before you can take a system apart, you first have to understand the parts. And if the understanding of the parts depends on our ability to read, then we have a fundamental problem, because on the one hand, we have an exponential growth. The body of software grows exponentially year over year. But on the other hand, I have a recyclability function that is kept at a constant speed because I can't read any faster. Well, actually, there's this joke, right, from Woody Allen, who said, I took a course in speed reading and I read War and Peace in 1 hour. And it's about Russia, right? So you can do that kind of reading, but it's not that's not the meaningful one. So I cannot really it is kept at a constant speed, and that's a problem. So the only way out of this predicament is that we're not going to create less software. The only other way is to make our understanding not be a function of size. And the only way to do it is through tools. And the only way to solve that problem is to solve all problems that are about software because they all entail somebody reading. So that's how we got here.
So is there a sort of a recycling effort within the tools then as well? Because obviously when you start up the system, a certain amount comes out of the tool with it. You can develop your environment as you go. What happens to that development that you've created on your environment? I saw a question where, as an answer to one of your talks, where someone had asked a similar question of like, I've created this thing. How do other people get access to this? I think your answer was you check it into Git with everything else. But my question is, how does that then, how does that sort of how does that spread across the rest of the organization if it's not just a single team? And also, how does that come back to GT? How does that become part of the rest of the GT ecosystem so that other people can get access to the tools that have been created in one company or another?
So this is so exciting because now we go into the economics. Like how does this work? Right? When would you create a new tool? And very often, right now, we see now more and more companies that have teams that are specialized on building tools. And their goal is to create tools. Now, if you look at what kinds of tools that they are creating, all of these tools, pretty much, the vast majority of those tools are about how do you build faster. Right, so we're always skewed towards the conversation that we typically have. How do you deploy faster? Everything is about how do you create something faster? And what we're saying is that, well, you should be applying the same kind of rigor. That's a great thing. You should be applying the same kind of rigor to how do you understand. So this is one. Second one is people very often ask about, what is the return on investment? So that's a typical thing we have when we encounter companies and say, okay, but what's the return on investment of creating these kinds of new custom-made tools, right? Because when people hear custom-made, they hear like, ooh, expensive, right? But and people assume here that tools are expensive. But what if tools are not expensive? What if tools cost 5 minutes to build? 15 minutes to build. Our target is usually 15 minutes. But in terms of like a goal, like in 15 minutes, you should see something of interest that is new. And of course, you can build more if you want, but or sometimes you have to. But a great deal of questions can be answered in very, very small chunks. So what happens when you do this? When the cost of the tool is cheaper than the cost of asking whether or not you should build the tool. And all of a sudden, you're going to find yourself building, throwaway tools. In fact, most tools that we create, we sometimes just use for 5 minutes. I'm going to create the whole visualization that I'm just going to use for 5 minutes. It feels so beautiful, and I'm so much more effective for it. And there's a whole new way of thinking. I don't have to think about reuse. Reuse is maybe if I say, oh, this is reusable, that's a great side effect. But I'm already profitable the first time I'm using. I do not need a repeating usage for me to get the return on investment. That's what we aimed for. That's what we are aiming for in our research and in our engineering. So how does this work? Now, of course, if I have a view that I really would like you to also use, I will simply commit this view next to the code that it's about. So I will put it in the same repository as where all the other code is. And then when next time we're going to take the next version, that code will enhance my environment. So, because there's always a tool for which you look at the system. You never look at the system, there's always something. People use an editor. You can also talk about that, right? So, by the way, where do people read code?
Well, yeah, that's all right.
Yeah, just say it again. Editor. It's a tool made for it was not meant to solve the reading problem. It was meant to solve the editing problem, and it was such a hard problem to solve, right? But now 20 years after, 30 years after that problem, we're still reading in an editor. probably the only ones, by the way. But so we should have an experience that is specifically targeted towards the reading part. By the way, the first thing you should do is not edit, right? You first have to understand before you edit. So the whole development experience is totally upside down, right? People start with the editing, and then of course it's frustrating because like, what do I do? And then say, oh, let's go and jump around, right? So you have these abilities of going through your code base, but it's like, oh, let's reason about the whole city. Let's evolve the city. And the only tool I give you is a magnifier glass. Like the magnifier glass is a perfectly reasonable tool, just not for that task, right? So the whole design is basically broken. So it has to be riffed on about that. So
I think that's interesting because actually a lot of the time these days, my preferred way of exploring code is usually via some sort of static analysis tool, because it gives me, a jumping off point based off, functions, problem areas, that sort of stuff. It seems to me that static analysis must be some inherent part in the Glamourous Toolkit.
Mm-hmm.
It is. Is that how the? I mean, what is that the jumping off point for creating some of these visualizations? I mean,
yeah. So when it comes to the static side would be like that, but sometimes let's say we apply the same kind of tools for reasoning about APIs. Like you would say, well, what do they have to do with like they don't fit in the same mental frame, because we typically have static analysis tool and then we have API tools that are totally different and rather expensive. And this is interesting because you think, if you think about, what is a static analysis? Well, represent your system into some data format that you can then traverse, query, visualize, right? And what is an API tool? Well, the API will give you a JSON or whatever, but typically a JSON, right? Mm-hmm. And what is that? It's a tree. That tree is not unlike our abstract syntax tree. It's actually, right, every program, if you parse that, you will get an abstract syntax tree, which is a tree. And the first thing you have a JSON on the one hand side, you have the abstract syntax tree of your code on the other hand. They're kind of the same, just a tree structure that you want to go and manipulate and navigate through. And then typically what you do is you have some sort of like you're going to build some sort of a model out of it. So, let's say you take some sort of, you import, you call an API and then you get some JSON with some data about customers, right? And then you have some products there, and then you have some customers, and then you have some links between them, like this customer bought this product, for example, right? And so you'll have a tree with long JSON, and in there are going to be IDs that will point to some other entity, right? So you're going to have this product or this customer bought this product, and then I'll have this ID of the product there. So what am I typically doing? I'm going to resolve those IDs, right? I'm going to say, okay, this customer, and I'm going to link the customer with the product. And all of a sudden, the result of that transformation is that I'm not going to have a tree, I'm going to have a graph. And I'll have, okay, here are multiple customers having these multiple products in common, for example. Now, do the same thing, but for code. So I'm going to have a class with functions, and in those functions are calling other functions. So they're going to have some, IDs, some names there, right? And I need to resolve them. And if I resolve them, I get a graph. So at the end of the day, I just have something that some set of objects that have connections that I should then just query. And the activity is pretty much the same. You're just going to apply it to different domains depending on the kinds of problems that you're having. Now, what's the benefit of that? Because they say, well, this sounds like this generic thing. The benefit is that very often real life problems do not fit in a specific analysis category. Tool vendors want you to see problems in terms of, this is a static analysis problem, this is a dynamic analysis problem, this is a blah, blah, blah kind of problem. But when you have an actual problem to reason about, let's say, how do I split these two components? Okay, I just have two components and I have to split them. So then all of a sudden you'll say, okay, maybe I want to reason about maybe I can just, write like a static analysis that gives me the dependencies between functions, and I'll see what should be, what should be cut. But it's not so easy because, well, I actually have to go first look into the API of these ones, because the APIs are okay to be used, but not the direct parts in the system. So that can be one. But then some people say, oh, but look, this component over here is actually writing something under the database. And this other component over here is reading from the same place. And all of a sudden we say, oh, okay, how do I reason about that one? I might try to do it statically if I know how, but maybe I should just go and combine that kind of knowledge, the static side of things, with the log from the database. And all of a sudden I need to reason about two pieces of information that don't fit in a bucket that a tool vendor would like you to think of. They cross those kinds of things. And so that's the problem. Typical problems, software is so contextual, we cannot predict. We can predict classes of problems, but not the specific problems you'll have. So we can't give you, silo types of solution. We have to give you an environment where you can weave whatever problem, however you see it in front of you. And then you're going to construct the tool that will then give you the summary that you're interested in. And so that's the flip. That's the flip side.
So we started this thread talking about products and do products.
Should they care about the IDE?
Should they care about the IDE? Now, I've heard you speak about this platform as a platform for storytelling in the past, which I think is a great description for how to read your code. Right, your idea is that you're trying to visualize your code. You're trying to find a way to navigate and tell that story. My question would be, again, back to the do product need to care about the IDE? How complex is this story? Because a lot of product people I've worked with, a lot of business people I've worked with, the visualizations that I would create, for example, on a whiteboard or a virtual whiteboard these days, now that we're all entirely remote, is very high level, and it is an abstract story to explain what's happening. It's not actually what's going on. And, I've used tools to try and visualize how things are connected, and generally that works well for an engineering team. But I do need to abstract it and put a narrative wrapper around that. Does this tool allow me to do that? Talk to me about that.
Yeah, so absolutely. So in fact, I will even challenge that those off-the-shelf analysis tools work for engineering teams.
Actually, I agree with that. I don't think that they particularly work very well.
So in fact, I see those tools being used. And it's not just visualization tools, but if you think about also static analysis tools, for example, and if you think about how people use those tools, is very interesting, because the way people use, for example, checkers, lints, or whatever, those kinds of things, the way they are being used is say, okay, I have this language, I don't know, JavaScript, so I'll just take JSLint stuff, and I see, okay, here's a repository of 1,000 rules. And from these 1,000 rules, I will take these 100 rules and I'll apply them onto my system, right? Now, there's an interesting thing here, because the interesting thing is that those rules, same rules, you're going to use them in your system. But okay, you're also using JavaScript, and you're going to use those, and you're going to pick from 1,000 rules, 100 of them, and you're going to apply them in your system. And now, so by definition, these rules must be common to both our systems, because otherwise they wouldn't be applicable there. Which also by definition means that they are unable to capture what's interesting about our systems. And the value of our systems does not come from the fact that we're using JavaScript. The value of our systems comes from all the things that we've encoded on top. So which means that by definition, those things are broken. Now, if you go back to testing, you never find a developer that downloads a unit test and applies from some other system and applies them on their own system.
No.
You never do that. Now, what do they do instead? What they do is they're going to stop and write the test themselves. And in this process, they will bake into the test the assertion there. it's going to encode what is valuable. And this is the reason why you'll find teams with 0 broken tests and 10,000 warnings. And it's not because because they don't care. It's because the warnings are not real. Because the warnings solve somebody else's problem. They capture somebody else's value. And that's the difference. So the technology is great. The way it's used is broken.
That bit I would agree with, because I think the way that I try to use those sort of linting tools and static analysis is to actually use it to set a quality bar that you say. In fact, actually, I found it to save a lot of time on pull requests, because if I can say, or agree with the team, these are the rules that we're going to apply to our code. These are the ones we're going to agree to. And the reason we're doing this is because of performance and security and all these other reasons. It saves me having to review a pull request that isn't ready for me to review. So it's a way of saving time.
Yeah. So reviews should be like exploratory testing, not like regression testing.
Absolutely.
Right. So as soon as you know what is not good, then you should delegate it to the tool to check it in the future. That's clearly true. So yeah. And now the only question there is like with tests, right? So the question is, how many of these rules do you create, right? Because if you've just created a huge chunk of code, but you didn't create any new rules, it's something's fishy there, because it means that there are lots of assumptions that just went implicit. Every one of those rules that you push into this repository being checked all the time, you have a chance of making some assumption explicit. And then the interesting thing happens when you're creating a rule and I have a violation and I disagree with the rule. And there's so interesting things that happen there. And then, by the way, this is what we call steering agile architecture. And there's a whole process there. Again, just like with DevOps, right? DevOps starts saying, we're going to decrease the cost of deployment. To do this, we need new tools, we need new skills. And by the way, this will enable whole new processes. The same thing happens here in moldable development. We're going to say, we're going to decrease the cost of a new, whatever you want, view, analysis, metric, whatever. We're going to decrease that cost to be so cheap that you're going to create them and maybe even throw them away after 15 minutes, and it's still going to be profitable. Now, for this one, you need new kinds of tools, you need new skills, and by the way, this will enable whole new processes. So one of them is architecture, for example, right? Architecture is, you never have an architect and many developers. Because if the only architecture that matters at the end is the one that is somehow reflected in the code, right? The code does not have the architecture, but the code reflects the architecture that matters. It follows that the only architect that matters is the one that changes the code. So it follows that you only have multiple architects, which means that all of a sudden architecture is a negotiation, right? The architecture is a commons that we have to, steer together. So whenever we have this kind of negotiation kinds of problems, the key question to have at the organization level is, how are you going to design the space in which the negotiation happens? So, 20 plus years ago, we used to notice, business and technologists, they don't talk to one another, right? There's this chasm between them. So how did we solve that problem? We made them talk, right? We designed the organization around this idea that they should go and negotiate, because they have different perspectives, right? So we introduced this feedback loop. Nobody today tackles architecture in any systematic fashion, and they should. And then, of course, as soon as you can create and put a picture on anything you want about software, you're also totally transforming how people think about architecture. So that's one of those kinds of side effects. And we get to, I kind of half jokingly say that if you want to have an interesting team building exercise, you get your team, put them in a room and let's talk about architecture, right? And then 3 hours later, people say, well, it was highly entertaining. It was highly, we consumed a lot of energy, and then there was no decision at the end. But it's interesting if you take the same team, and instead of talking about these abstract problems, and instead of allowing people the what ifs, because those are the problematic ones. If you say, we can only talk about this thing for which we have data, right? And we say, this problem, I have this problem, I don't like how this piece of code here is because of this reason, and there is a tool that shows me that. We find that people find a decision, a common decision, they find a resolution within minutes. In fact, if we do not find a resolution within 5 minutes, we break it. We break the conversation because it means that we don't have good data. And this is how we steer with the whole team architecture for the long run. And it's interesting. This is how we steer actually large migrations, basically. And it's very, very effective.
I can see how that would work on a very detailed level for, we're working on this piece of software and we need to take it from this particular point to that particular point. What if you're dealing with an organization that has, 10 plus teams and, hundreds of microservices, some of them monoliths, some of them microliths, some of them whatever hell you want to call them, and various different front ends. How do you have the conversation to say, okay, guys, actually what we need is an entire paradigm shift. The platform needs to look like this because that's going to enable all of these different things. That's not something that you can necessarily, it's something that's a bit more abstract and you need to sort of build culture and vision around. You're getting very excited. I'm looking forward to this answer.
No, so it's like, this is, one of the key reasons people call us, not key, but like we see a recurring reasons people call us is because they want to split their system into microservices, for example, right? And very often we ask them, so why do you want to do that? And then they say modularity, and that's like totally the wrong thing, right? To split your system into microservices, because the problem is like people. The thing is, people are looking at the microservices because they give these constraints, right? They're like this, right? You put this code over here, and this code cannot call this other code, right? Because it's in the same virtual machine. All of a sudden, I can call. It's a free for all. So, but you put them into virtual machines and all of a sudden I can't do this call. So this is so great. But what they're really begging for are constraints. They don't want microservices. They want constraints. Now, when you think about constraints and then the way, microservices to pay microservices price, if microservices price for just having constraints, it's a terrible economic proposition. But constraints can be much, much cheaper to add, like much cheaper. Like you could create constraints, they should be ridiculously cheap to create. Now, when you can create constraints very, very quickly, and when I can start having a conversation with you about what I'm finding with data, the whole conversation changes. So that problem that indeed at the beginning, right, that problem is abstract. No, we need this company has to grow 10 times, right? It has to have 10 times more customers in 1 year. So that's like that's an interesting problem to have. But then if you look closer and say, well, maybe not everything has to be 10 times larger. Just these two services. Right? But you have to go and dive into that one. So at the beginning, everything is such a large problem. And those two services, actually, not everybody is involved in those, just a subset of your 10 teams. And so you're going to go and talk with them. But then if you look closer into those things, then you'll say, well, actually, they need to scale slightly differently because of whatever reason. One is a batch job and the other one is a direct, client-facing type of application. And so now you're going to start reasoning about that one. So yes, you do start from all problems appear difficult and abstract at first. And the way you deal with them is you split them. Now, the fractal-like property is so important because we are trained or we got induced into this idea that large problems should be served differently than small problems. But they are not. Tiny problems, an object, like the way I reason about an object is actually, I'm going to use exactly the same tools. I'm going to use exactly the same techniques as the way I'm reasoning about the very large ecosystem of, 100 plus applications. And the way we actually reasoned about that one was we didn't even look at the code. We only looked at logs because it was a much more interesting source of information. And that was the input for how people should steer the conversation that they were having there.
I think that's a really interesting answer. I think you're coming at this from a slightly different angle from some of the other people we've had on the show before as well, which is interesting. So let's just approach that, sort of reframe some of that stuff. So, for example, we had Fred George, the grandfather of microservices, on the show on episode 14, and we had Auden Strand on episode 17. And From spending time with Fred particularly, and obviously he influenced Auden's solution as well, I don't necessarily think that... I mean, Fred talked about the dangers of microservices, interestingly, as the grandfather of them himself, and not every problem is a microservices problem, which is exactly what you've just said to us. But if you took Auden's specific solution, where, they've gone from 4 releases a year to 1,400 a week, which is an astonishing transformation. Yeah. I don't think you could have necessarily started on that without having an abstract vision necessarily, because I think quite a lot of stuff had to change dramatically for that. And yes, to your point, they didn't change it all at once.
Yes. That's it. That's exactly it. Right? Your system does have to evolve, but is your problem 100 times larger than it actually is, right? Because it matters a great deal. If I can take that problem that looks like 100 pieces, and I can take it to 2 pieces, all of a sudden it's manageable. I can do something about this. That's the whole point. And if the problem is 100 pieces problem, then it probably has 100 problems in it. That's the other thing about it. Right? That's exactly it. But how do you then visualize every single aspect? This is why it's so important to start having conversations about the inside of software systems. So now going back to, should the business care? Should the business care? And that's the interesting thing, because I'm also asking developers, do you agree that architecture is as important as functionality, at least in the long run? And they say, oh, yeah, sure, of course, right? Right? Of course.
Well, it's a means to an end, isn't it, really? I mean, that's the thing.
I'm not disagreeing, just like how functionality is a means to an end. Right? Because we shouldn't build functionality for the sake of functionality. We should look at what people are doing with the system. That's the end user. That's the end goal, right? So both are. But if one is important and the other, if they're equally important, it follows that we should treat each of them with the same rigor, right? Because it kind of makes sense. So, for example, do you test functionality? Right? People say, yes, right, great. Okay, do you test architecture? No. Okay, good. So maybe that's the first point, right? You should go and deal with. So,
I mean, I think you should. I mean, I think to your point, there are a lot of organizations that don't. And it depends on, how rigorous you've got your testing frameworks, because you should test, but then you should also load test and performance test. And, that's the test of your architecture. That, as well as how fast can I build in it? How fast can I ship in it?
I know, I agree, right? So, but the same thing is also with, when you think about functionality, people will say, that they would put even value on it. Say, wow, if you can do this, it will lead to this type of added value, and you can even put money on it. And it's an interesting thing. But then you get to these architectures, like, well, how do you put money on structure? And that's like it's a reasonable thing. People shouldn't think so much about money, but when it becomes immediately obvious is when people have to change the system, right? They have to re-platform for whatever reason. And all of a sudden, the only thing that keeps them back is architecture. And so, and it's at that moment, right, when businesses realize, oh my God, we actually have this, but it's not on our accounting. And it should be on their accounting, right? The architecture of their system should be on their account, because it's the thing that threatens the whole business. If they can't digitalize properly or adapt properly, it will affect the business. And that's the problem. So it is important. It is as important. So why is this never, why nobody cares, right? Because you were saying, like, when you were we're just drawing this abstract thing on a whiteboard or whatever, and when we're drawing it by hand. First of all, we're drawing it in the abstract because when you're drawing by hand, it's very tedious to draw, 1,000 little details. To draw it by hand in a single session, so that's going to be difficult. So That's why you need kind of.
Well, I agree with that, but most of the time I'm trying to find a model, a mental model to explain the architecture.
Mm-hmm. But you're going to need mental models at every level of abstraction. Why?
Yes,
right.
Absolutely.
So one of the things we notice is, like, I remember about maybe 10 years ago, I opened my bank account, my online bank account, and then I paid the bill, and then it hit me. It didn't feel bad. So what happened was that the UX, the user interface, and the experience of using the online interface changed so much and improved so nicely that I didn't feel bad when I paid the bill. And I found that's an amazing achievement, right? Because like you take this inherently horrible experience, like, who wants to pay a bill, right? And then you transform it into something that is not negative, which is, I think this is an incredible thing. So which means that there is a way to translate computation in a way that normal humans can find enjoyable. Now, why do we limit this only to the outside of the system? It doesn't make any sense. And there was a whole skill, right? And this ties back to the storytelling side of things. I think that in the next decade, we're going to see companies hiring storytellers as key roles inside the team. And these will not be storytellers that will tell stories necessarily like marketing stories, so to the outside people, but they are going to be translators, people that will find mental models that are interesting to communicate across about the inside of the software system. And we will also start to see these things being used actually as marketing tools. So for, one of my hobbies is to watch Apple keynotes, which are not so good anymore, but they used to be really exciting. So one of the interesting things that hit me was that when they introduced the MacBook Air, they floated around the room just the case of the MacBook Air, just like, who cares about the case? And yet they made it a point that case is an interesting, super interesting thing. It was like this unibody, whatever, which of course, like, there's a whole marketing in it, but there's such a beautiful engineering problem that was being solved there, right? And it was like an interesting point. And since then, if you look at the keynote, you're going to find that a significant amount of the keynote, which is one of the most valuable marketing events in the world, right? Like, where you have tens of millions of people tuning in to watch a 2-hour commercial. That's like crazy. So, and you're going to find this a significant portion of this keynote time is going to be spent on people showing you the interior of the hardware. And that's like a crazy thing coming from a company that goes to enormous lengths to preventing you from ever seeing the interior of the device, right? And you would say, like, what's up with that? And it's like, it bothered me for like a couple of years. And I figured out once I saw this interesting TED talk about from a designer, and he was talking about how he looks at design, and he was telling the story about this clockmaker at the beginning of the previous intro, and the clockmaker, right? They were making these beautiful clocks or watches, and so the one person goes to the clockmaker and then that something was wrong with the watch, and then they took it apart, and as they took it apart, the customer saw that there was an engraving on the back of the case, like just inside the case there was an engraving, right? So not something that the customer will ever see, and then he asked the watchmaker, why do you have an engraving on the back of the case? And then the watchmaker, because like nobody can see it. And then the watchmaker said, God can see it. And that's a beautiful thing. Like, I just felt something. Like, it was just it's just a beautiful TED talk. Maybe you can link to it afterwards. Sorry, that's exactly the point. There's a very interesting correlation between inside beauty and external economic value. So, for example, when Apple started to have this idea that hardware has to be beautiful inside, right? They were competing with the Dells of the world, right? Which were producing these horrible looking machines, even on the outside, but in the inside, they were even more terrible, right? And we saw what happens, right? So in the meantime, right, the value switched completely towards the side of the beauty now. And they're not the only ones, right, that are doing this. You're going to see more and more of these kinds of patterns when people are showing you the inside of a system, of the hardware, like cars, for example, are like that. They're going to show you the inside of the car, even though nowadays you can't even open that car anymore, right? Now, not even Apple, which understands so well the value of the inside beauty, ever talks about the inside of their software systems. And that's because, as an industry, we don't know how to have that conversation. But once we are going to have that conversation, there's so much economic value that we can unlock.
Do you not think that some of that is due to the IP as well, though? Because, I mean, when you are demonstrating, the value of a PCB, that is something that you can open up and take a look at. You could open up the back of your MacBook and take a look inside, and a lot of those components are standard, and really they don't work unless they've got the firmware, and they don't work unless you've got the software. And actually, all of the software and the firmware is all binaries anyway. That's really where the core of the IP is held. So, I would argue that they wouldn't publicize that anyway.
Yeah, well, I'm not going to talk about Apple now, but it's interesting to note that Safari actually is based on an open source framework.
Yeah, I don't mean all of it, of course. I mean, I think Mac OS and stuff like that, I can imagine them wanting to hide.
Yeah, but we can understand. Okay, yeah, Mac OS, maybe there's a lot of IP there, but WebKit is free and open source, and they even tout it quite heavily and say, "Oh, look how fast it is." But they still never show you the inside of the system. But then you would see, okay, maybe Apple, maybe they're doing it inside, right? Maybe they have this beautiful representation of their systems inside the company, right? But if they have it, then maybe somebody else has it. Have you heard of any that are systematically enjoying looking inside their systems? Because I do. I love looking inside a system, and it's not because I'm a masochist. Right? And so coming back to the question, should the business care about the development environment? Yeah.
Well, I think
they should. That can translate.
Yeah, and I agree with you that they should care. I think that there is probably there's a lack of technical understanding, though, across the board. And I mean, I find it quite frustrating because, I mean, we have great conversations on this show with, a wide variety of people. And I think personally that, this talk's probably been deeper than most of them, actually. But a lot of our conversations are quite accessible, in my opinion, to non-technical people. And I think there is a thing around technology where people will often say, "Oh, I'm not technical. I don't want to get involved with that." And I think that is, that's a pervasive problem in our technology businesses, and in a lot of businesses that are technology businesses but don't actually realize that they're technology businesses. And so I'm on your side with saying that they should understand it. I think we could probably debate about how much understanding they should have, in the sense of, do they really need to go right the way down into the code? I mean, my background is Amazon, and we had a principle there that you should be able to dive deep, and most people can actually go and dive into the code, which I think is a great asset. And again, you talk about Apple, Amazon has also skyrocketed in the last decade for stock price and share value and that sort of stuff. But I think it would be great if we could encourage more involvement, if we could encourage people to think that they could access that code and understand it in more detail. But I think that is a whole, complex thing. I'm wondering if you've got more of an exact example, because you've talked to us outside of the call about, for example, Poly, where you've implemented some of these tool sets, and you've also talked about within your own organization as well, where you have no meetings, no schedule, no planning, no backlog, and yet you still manage to get all of this stuff done. So I'm wondering if you've got any further sort of organizational insights, or how do you apply this and actually get everybody in the business singing from the same hymn sheet, to use a terrible phrase.
Right. Yeah. Thank you for bringing that one up. So just briefly with Poly is an interesting company, and whose goal is to take the data economy in Europe and turn it upside down and empower the individual to own the data and be part of the data economy, not a passive part, but an active part. Now, so this is that undertaking is not it has a technological component, but there are the economic and the law components of it are much more interesting. So we needed to have a conversation with the multiple stakeholders to figure out what's the direction, what's the interesting thing there. And this was one of those interesting case studies for us, because we could also participate in the raise funding. Right? So the executable models that we created in the environment about the domain were actually useful for for example, for investment conversations, for example. And that's an interesting thing. Now, to bring back to the organizational side of things, we do work with in a rather peculiar way. So we have no meetings, no scheduled meetings. We work remotely, which is no longer so unusual today. But we also have no backlog, and we have no schedule. So the way we look at it was, we said, well, we were engineers, all of us, so we didn't like management. So we said, well, what requires management? So, and then everything that required management, we said, okay, out with it. So what requires management? Okay, we have meetings, they require management, so we shouldn't. So done. What else? Well, planning, right? So the interesting thing about the planning is actually the fact that we have to go and guess the future. And because we are all engineers, we know that we can't do it properly. So why even pretend? So we didn't even go there. That was easy. The more interesting thing was the backlog thing. Like, so we have a set of issues, but they are not ordered. And you think about, like somebody has to go and order issues, right? When this whole idea of a lean thinking is when the issues are ordered, and then people are just taking arbitrarily the one that is on top of the queue, and that's like a funny thing, because again, as I said, somebody has to order them. And did you notice this behavior, like when you put in the queue structural and functional tasks, and all of a sudden you find there's this process of sedimentation, I call it, where the functionals float on top of the queue, and then the structural things go at the bottom of the queue.
You find architectural ruins in the midst of your backlog. Is that what you suggest?
Exactly right. So no, the thing is, like, of course, this is going to happen if you're going to ask people that have no idea how to evaluate those tasks. Right? If you delegate it to them, then how can they possibly make a proper decision? They can't, right? And we shouldn't delegate it to them. Instead, it's much more interesting if people would understand what needs to be done and make decisions. But in the broader sense, we look at this. We look at an organization as a system, and you can think of systems like, maybe, let's say, two extremes. Like, one would be like a sequential type of a design, and the other one will be a completely asynchronous type of design. Right? And then you have the in-between ones, which are the horrible things, which are like kind of, they pretend to be distributed, or asynchronous, but they have synchronization points. Right? Those are like the worst kind of designs you can possibly have. So either you say, oh, do everything one after the other, or do everything in parallel, and then eventually be in a consistent state, but just don't do in between. Now, all these agile things that we have floating around, they have this kind of, they're in between, right? They are kind of like, oh, people should be autonomous, but they should synchronize at this and this and this and this point, because all those meetings and stand-ups and plannings and so on, and the backlog and whatever, those are synchronization points. And they come at a great cost. So we removed those. We have no synchronization points. We have eventual consistency. People have to fight, for example, to get the build green, but that's the only synchronization point that we have. Now, what we do put in place, however, is something else. The reason why people also have these meetings is because you somehow need to get the node to eventually know something. So people will say, well, it's much more interesting we're going to spend this time to, and then there are whole sorts of rituals, right? We call it planning and daily stand-ups and so on.
The ceremonies, yeah.
Ceremonies, but two, with the goal of actually having a chance to communicate what you want to communicate. Because if you can eventually rely on the fact that people will actually find this information out, then you might not actually do it. Maybe you can choose not to do it. But if you know that they will never know, then you say, well, actually, let's stop and let's pay attention, right? So, and then you have this. So, for example, mob programming is so interesting today, is because, right, that's a serial thing. Like, it's just a sequential thing. There's nobody pretends it's asynchronous. And that's great, right? That one works so well, right? So we are on the other side of the spectrum, but we put something else in place. So you mentioned storytelling, and we do think that this is so important. It's such an important skill in software development. And we realized, in fact, about 3 years ago, 2 years ago, 2.5. So before the pandemic, I realized, I was asking myself, why exactly is it working the way we work? Because I started looking at the literature, and there's nothing in the literature that would say this thing should work. We should not be able to produce anything of meaning. And yet somehow we do. And that was like a puzzling thing. And then at some point I realized, and I looked back, and I saw that we use a chat tool, and I saw that we were exchanging about 10 pictures per day. Pictures, right? And I'm not talking about GIFs or so. I'm talking about pictures about the inside of the system. Because we can make our environment. So we use Glamourous Toolkit, of course. So to develop Glamourous Toolkit, we also use Glamourous Toolkit. So anyway, there's an interesting thing there, right? So that means that the skills that you need, the skills you learn to reason about your systems, are also be exactly the same skills that you're going to need if you have a question about the tool that you're using to reason about your system, which is an interesting problem. But so we're using Glamourous Toolkit. But the exciting thing here is that when I communicate a problem about my system, I'm not going to describe it in text. When I'm talking about storytelling, I'm not talking about textual thing. People are crazy today. People are talking about, the writing skill. I do believe that the writing is important, but it is not the most important. The most important one is the skill of compressing communication. And the way we compress communication is by creating the pictures, contextual pictures that show exactly the problem that I'm interested in. And I very often find myself, here's a picture with a problem. I don't understand this. And then somebody gives me an answer within minutes. And that's it. That's the whole conversation. I just send the picture with maybe a question, and they give me either another picture or maybe they point me to something. And that's it. So when the cost of conversation goes down dramatically, I do not need the ceremonies because I increase the likelihood of communication.
Well, I think that communication one is the interesting point for me, because actually, you say no meetings, no schedule, no planning, no backlog, or no prioritized backlog, to be more specific. And I do want to come back to that in a sec. That's not wholly removed from the Agile Manifesto. It's
No.
it's not Scrum, clearly, but it's not wholly removed from the Agile Manifesto, which
Of course.
everyone can go and look up on agilemanifesto.org. It's been there for about 20 odd years now, I guess. But that says specifically working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. And the last one, which I think is the one I want to query you on a bit more, is the individuals and interactions over processes and tools. Because it does feel like you've replaced some of the interactions with tools, but you are, which is the nature of this conversation. But it feels like that tool is the communication method. Would that be correct?
That is correct, right? We didn't know it up front. This was an interesting side effect we learned. That this is what it led to. But yeah, so I think tools should not be the focus, except they should be, because tools, they make us think in the way the tools allow us to work, and that's a deep problem.
The tools that they reference in the manifesto, think back 20 years ago.
Yeah,
obviously, SmallTalk was around, but the tools that they were referring to were probably not those. It was probably more things like Team Foundation Server and probably, this will predate Jira and a whole load of things that I'm familiar with, but Team Foundation Server was definitely around.
I know. So I'm not saying that I think that, the Agile Manifesto was a crazy moment in time, and I think it did so much good, whether by intent or not. But I just think it did a lot of good. But of course, it was good at that time, and at that time, I wouldn't have known how it should be enhanced, right? So if you look at, for example, DevOps, it's not like DevOps is not or is contradicting the Agile Manifesto in any form.
No.
But you would have not been able to discover the DevOps just by looking at the Agile Manifesto. So that's all I'm saying, is that there's these complementary perspectives.
Well, I think DevOps is always a very interesting one, because if you were to go back to how we would develop code or build websites in the early 90s, you would make those changes pretty damn quickly, and you'd make them probably on production. Really, all that's happened in the last 30 years is we found more safe ways of making those changes. Because we've gone into that sort of ITIL world, in the last 15 years ago or whatever, is probably the peak of all of that. And that removed us and slowed us down from making those changes. And now we're sort of back to where we were in the 90s. We can make changes that fast again, except now it's a lot safer to make those changes. We've gone in a whole circle.
Yeah, absolutely. No, I agree. And what is, again, for me, the more interesting thing is that how the ability to make change affects the way we think about the business. Like the nature, there are whole business models today that were probably not predictable 20 years ago.
That's true.
Right? It's because a whole new conversation, once you start a conversation, once we decide that something is important enough to have a conversation about, the evolution of the space is so that you can't predict it before you have the conversation. And that's the beauty of it. Right? And this is why, right at the beginning of the podcast, right, we started from, let's talk about the solution. And I think it's much more interesting to talk about the problem. Because as soon as we start talking about that problem, in 5 to 10 years from now, we will simply not recognize the guys, the kinds of solution that we'll have then are not predictable today.
No, I agree. I mean, help some of our listeners who might be thinking, actually, there's no meetings, no schedule, no planning, no backlog.
Oh, he'd love it. Yeah. So this is interesting, right? So first of all, who puts stuff in the backlog, right? That's another whole thing, right? Like people put it on the backlog. So somebody puts it on. Anybody can put it on the backlog. And so that's one. The second thing is, how do we get stuff done together, right? Because it sounds like, oh, it's like a free for all, right? We don't even have to have schedule. We don't even count hours. So I don't know how many, how much time people work. But we find that our main challenge is actually getting people to take holidays. So we have the policy of having a minimum amount of mandatory holidays. We don't have an upper bound, but our problem is to have people at least take the minimum. So, which is, I'm not saying that this is great, because I think it's, like there was a recent tweet that I saw recently. So somebody said, if you want to make someone miserable, pay them handsomely for their hobbies. So, so that's a, I think it's a negative thing. So that when people overwork, that's not a good thing. So it should not. I agree. Yeah, no, so I agree. I just say that, like when you look at, for example, burnout, is like you only recognize it. It's difficult, if the medium is conducing in the wrong way, then you only want to recognize it when it's too late. All right, you don't want to recognize burnout when after it happened. You want to prevent it from ever happening. So, but anyway, that's another conversation. But so, how do we go and do stuff together? Well, but everybody can do whatever they want, because at the end of the day, every single developer anyway does what every single developer wants. They do exactly what they want, right? So all that PR thing, like when you review the PR, that's just, they're just dressing everybody can put whatever they want into the system, pretty much. So why not embrace that? So why not have business runs after developer rather than developers trying to pretend that they do kind of like what the business does, right? That doesn't make sense. So that's one. But the second thing is more interesting. And we see, when you look at it as a business, then there are opportunities. And there are opportunities that are not visible if you're just looking at the system top down, right? You have to look inside from the bottom up, and you say, oh, look, if I could just took these two components and make them one, I could make my whole system more expressive, and we have it with less cost. It's so expensive to explain this one to somebody that looks top down. It's simply just not possible. So we don't pretend. We simply say anybody can do whatever they want. And now the only thing is, if you want a second person to work with you, well, now you have to convince them. And so now you're putting pressure on this conversation, on the communication side of things, on the storytelling side of things. And so this is why, right? What's the biggest problems companies have, right? If you go towards the leaf of the organigram and ask them, why are you doing this? Right? And you'll be hard pressed to find, 5 out of 10 engineers knowing why, right? Having the same why as the one on top. Tell you the same why as the one on top. And that's a big problem, because if you don't know the why, you also have no clue about what trade-offs make sense. And all about engineering is about trade-offs. So the preserving of the why is so important. That's why storytelling is going to be such an important skill, because we need to preserve this why, because that's the only way to create humane technology. Today, we are oppressed about the technology that we use. Just look at the social effects of just losing social media over the last year, right? Both on the election side, for example, but also, just in how we are dealing with the pandemic. So that's why I think the way we work is not that I think, but the way we work. The reason we work the way we work is because we simply say everybody has a say in the direction of the system. and they can actually take the lead. And we do find that people, maybe I'm going to lead certain things, but when I say lead, I can't tell people what to do. I can only convince them and say, well, I think this is an interesting idea. I would like it like this, but they have to agree with me. And if they agree with me, then it's great. We're going to do it. And if they disagree with me, then it's also great. But I'm going to ask you, why are you disagreeing with me? And then they're going to explain it. And they'll say, wow, okay, that's an interesting perspective. I didn't realize that. And then I'll update my mental model. And so it's a continuous dialogue. Like this. Now, will this work with 1,000 people? I don't know. If you look at the work of Simon Wardley, the kind of studies that he's doing more recently, I think he'll say that this should work at that size, right? And if you're looking, like you were talking about Amazon, in your experience with Amazon, not exactly the same, but kind of the same, right? When you have your teams now becoming the drivers of some change, and then having to work with these other teams in their nearby environment in order to affect some change, right? And if you add to that this ability to create this kind of testing contracts, for example, that's a way of also another way of compressing conversation. But I think there's much more we can do there.
Yeah, I mean, I think to go to the Amazon example, they very much had meetings and schedules and planning and backlog. And actually, no matter what you hear about Amazon not using PowerPoints, that was the main focus of our main meeting, was to have like a 120-page PowerPoint that was a summary of every project that was reviewed in 60 minutes once a week. That sort of stuff was how we actually managed it, and most of it was done by a vision, really. So actually around what's called a PRFAQ, which is a press release with a set of frequently asked questions, which I think we might have touched on that in the Ben Lavender episode. But essentially the idea is you don't describe the technical solution. So there is some element of this that does cross over, where you say, this is the customer vision of what I want to achieve, and then you give that to the engineering teams and they figure out how to build it. The rest of it is a coordination effort. And for me, that was back in 2011 or whatever, when there wasn't a scaled agile, trying to figure out, or there wasn't a scaled agile that I knew of anyway, trying to figure out how to coordinate 45 teams that were in 3 different continents, that you just sort of make it up and figure out how to make sure that everyone can communicate in the best possible way. There aren't even tools that can allow you to do that. So the best method you've got is communication, and going back to the first principles of the Agile Manifesto.
With the lack of synchronization, then do you find the workflows, the processes that these teams have, and even the coding styles, do you feel like they sort of all average out then, as everyone's doing their own thing but being considerate of, well, I need the support of my team or whatever? So do you find there's an average that sort of sits within the whole company, or is it still anarchy, as we put it?
So, it's the... So first of all, we are not a large company. It's just 10 people.
Okay.
But we do find, but we cover a significantly large space. But we are going to find that people, the way we use our chat tool is slightly different. We have channels, but the channels are named not by the topics, like, this component, that component, or development and whatever. The channels are named by pairs of people. So we have public channels that are named after pairs of people. And what we are actually simulating is a kind of open space where people just pair, and then you can overhear what they're saying. Mm-hmm. So kind of anybody can jump into any conversation, or not. It also means that there's a very cheap way for me to go, and there's a very encouraged way for me to, contact somebody. If I want to have an opinion, or if I want to work with somebody, I'm going to go and directly contact them, which might appear disturbing, but it's much closer to mob programming than to this, for example, this idea of when people have a task and people are talking about context switching, and there's context switching here, but there's a very interesting thing that happens when the task is not given to you. When the task is something that you have chosen, the motivation and the way you go at it is totally different. So there's some combination of that. So I have never seen an engineering team work remotely as productively as this team.
That's crazy.
But again, like, this is totally subjective.
Yeah,
It's just an opinion. This is one data point. I would not recommend people to just immediately go and abolish everything, unless they put moldable development in, but only after they have practices for 2 years, maybe, to know that they can do it.
Yeah, there's probably lots of little things that you aren't even thinking of that contribute to the fact that this works, and
I'm sure, and it might just very well just work for us. This could also be a thing.
So with all this, again, anarchy, and you building your own tools, how many projects or tools or software is built that is then thrown away? Is there quite a high turnover?
Oh yeah, we probably throw away about 2/3 of our code.
Wow, that's pretty high.
So so I mean, just think of, it's crazy. I read with people and say, well, so let's say you're showing something, it works, and then have you ever thrown anything that worked away? And most people we meet, they don't even, find this question to be really like a strange question to ask. Like, what would you throw it away if it works? Because, like, remember when I said that architecture and functionality should be equally important, which means that if it doesn't rhyme well, then maybe you should not. Maybe you should go and rethink it, right? Because otherwise, the implication is that you got it right the first time. There's no other explanation about that, right? And we don't know how to get it right the first time, so maybe it's just us, and that's why we're gonna stop. And the question is, when do you stop? When do you stop and go and rewrite some of it? And maybe you're going to rewrite it now or maybe later, but the question is when. How do you know? And the way we know is when we do not like the story told about the inside of the system. And so many times, we have all the tests were green. All the tests remained green. We didn't change the test, but we completely refactored the structure of the system just because we couldn't visualize it properly. And so this is when we realized that this moldable development is actually, it just exercises design in there's an orthogonal force. So if you're just looking at it from a test-driven development perspective, just guiding it through functionality, you're just going to miss a whole lot of forces that otherwise should drive design. And so we actually did an experiment for a couple of years with several teams of students that were in at the master level, and we were giving them no, actually they were not. They were at the beginning level. So we were giving them a very, very structured a project, right? So I think it was an Android app. And we not only gave them that, but they gave them these are the libraries, this is the setup. The only thing you can do is just change the code. Like, you can only change the model of it, and that's pretty much it. And they were all tested in the same way. So we gave them this for it was a whole semester, so 10 weeks or so worth of work. And then we looked at the results. And it's interesting, even after like a few weeks, like 6-7 weeks, when they were having 10, 20 to 50 classes or so, and you look at the structure, so you would say this app should be quite similar. I mean, it's super constrained. Like, it's like not that they could choose they couldn't choose the libraries. They couldn't choose any coarse grain paradigm, and they were tested in exactly in the same way. You would expect them to produce a similarly looking system, and even after just a few weeks, the structure of the system looked completely different in all cases. And we've repeated this with a couple of dozen teams. So the thing here is, if you're constraining your system only from a functional perspective, only through testing, you simply are not in charge of your structure. So the structure goes anywhere it wants. That's not a good thing, if you think that that's something that the business depends on.
It makes perfect sense. If you're not proud of the insights, you haven't got a hold of it, then it's a wild horse.
Yeah,
I think.
All right. Well, I mean, I think that's been a really insightful talk. Have we got everything? Did we cover it all?
In 2 hours, I think we have. Yeah.
It's been a long one. It's a challenge for the editor.
I don't think there's anything to cut out. I think there's nothing to cut out.
I think that's it. I think it's all good.
I think it's it. We're
good
done.
To go.
Ship it.
Is there anything else we didn't capture that we should have captured, Tudor?
Well, I think we talked about all sorts of technical things, but and every time we talk about we showed we built this tool, Glamourous Toolkit, because when we were just talking about things, nobody listened. And now that we built the tool, people immediately want to go and play with the tool. But it is not the tool that is interesting. The tool is merely there to, we want to start the conversation. That's our goal. We see our mission is to make the inside of systems explainable, but at the end of the day, we are not the ones making it explainable. It has to be the people that are building those systems. They have to make their systems explainable. And that, it is not a tool that will change that. It's a way of thinking that will change that. And the reason I was mentioning, software environmentalism is that I don't want my kids to live in a world that is not understandable for them. Because, the world we live in, the world we construct today, is increasingly a software world. And it's crazy things like if you look just at the last year, how a great deal of the society could continue creating value, even though there was such a disruption that came in our lives. I think that's an amazing thing. So there's an enormous opportunity that we have as a society, but we also have to pay attention to the negative sides that we create with the technology that we build. And as the way I look at technology, I see it both as defining the rules by which the society works, but also enforcing those rules. So in a way, technology becomes both law and law enforcement. And we just cannot afford to have our society work on top of a black box. It can't work. That cannot be the future that we should create. And so that's the reason why I would like people to start having this conversation. There's an economic imperative. That's the good news of it. So that's the moral thing, right? The good news of it is that there's an economic imperative. Like we literally can say, we can take that 50% of the budget and improve its performance by probably an order of magnitude without a lot of effort. The good news here is that, by the way, the skills are already in-house. They are just not made explicit. But it's not as difficult as people think. So it's like how the DevOps thing was not that difficult, in fact. But then there is also another imperative. There's another argument there. Because if maybe the morals and the economics don't work, maybe the fun part should. Like today, when I talk with developers and they say, well, do you love working with legacy systems? Right? That they find this to be such a strange question. Right? They even shiver, right? They visibly shiver. And I think that's such a pity because software is enormously beautiful. It captures how someone saw this world. It's like the most tangible form of philosophy that we've ever experienced as human species. It's incredibly enjoyable. It should become enjoyable. And so the one thing that we see with moldable development, and the people that are now starting to take it on, they report enjoyment levels or increased enjoyment levels. Like they literally smile inside the software system. And so these are the things that I think, or I would like, people to start talking about.
Well, I think that's a fantastic note on which to end. So thank you very much for your time, Tudor. It's been a pleasure to talk to you.
Well, thank you very much.
It's been great.